I'm really excited to be here, but to tell you, about 3 weeks ago, we had an event at the IMTS show. This is a major manufacturing show in the States. We had about 600 people, and we got them all excited about additive manufacturing in metal. And we have here an interesting community in the UK, because when it comes down to additive, you have very early adapters here, very innovative companies. Companies that have taken on additive manufacturing at a stage when others did not really seriously consider this as a technology. But now the challenge is, does it go on? But let me take you to the journey of additive manufacturing at EOS, and I just take you back 30 years, okay? We are now in the mid-80s. And this is when I got my idea, when I developed my first step of the vision. I'm at General Scanning. General Scanning at this point in time was a world market leader in laser positioning equipment. Before, I had been working in a startup in Germany in the laser material processing industry. Today, this company, I was employee number 11. Today, this company has thousands of employees. It's part of the Rofin Group, one of the major supplier of equipment for the material processing world. But back in the 80s, we were the first making a laser marker, taking a laser beam and engraving whatever you can engrave. And you can imagine what happens with this industry over the last 30 years. At this point in time, a lot of startup companies, a lot of them don't exist anymore, some made it. But I think when you look at the material processing world, laser material processing world, you see something that's comparable to what you will see probably in our industry. But let me go back 30 years. I'm working for General Scanning, being their European manager. I'm sitting on the strategy board in Boston, and we were thinking, where should we take the company in the future? And the founders had the idea, why do we only sell the key components? Why do we not sell, let me say, higher value add modules and maybe end-use systems? And at this point in time, I was invited to a presentation in California to a just newly created company. This was 3D Systems. And we were talking to Chuck Hull at this point in time. And Chuck explained to us what he had in mind to build layer by layer parts. He even used the expression 3D printing at this point in time. And one of my colleagues has sent me last year, when he heard about the success of additive manufacturing, 3D printing hype, he sent me a video which was a company presentation of 3D Systems in '85, just after they had started the company and had applied for patents for doing layer by layer photopolymers. And I looked at this application and I said to myself, what would happen if we could take this technology to a different materials world? I mean, I'm not a materials expert, I'm a physicist. But at this point in time, I was looking at these photopolymers, could imagine what the limitation of photopolymers were. But I said, why not to make metal parts? Why not to make ceramic parts? Why not to go into production? It's a unique opportunity if you take a design layer by layer and you build parts layer by layer. So this is when I created my idea to build EOS. And at this point in time, I proposed to the top management of General Scanning to just allow me to start a division called EOS. This was my code name, EOS, for electro-optical systems, because what we did at this point in time is we were developing the 2D world. 2D means reading and printing in in reading and writing in 2D. And after I had seen the presentation of Chakal, it was clear to me that we can take this world to the 3D world. And from my background, I'm a physicist, it was clear that opening up the design space would create a huge momentum to the manufacturing industry. At this point in time, we had already a lot of experience with laser material processing, which means laser welding, for instance, was around at this point in time, and we equipped the first factories with laser welding equipment. This was normally using one of our scan heads, a laser, and just the application was laser welding. So the idea was to take this into the metal world, into the real world of serial production. But my top management didn't accept my proposal. They said, this is much too risky, we are too far away from the real world, and there will be a lot of patent litigation, and we do not want to entertain this. You have to make a decision. Either you stay with the company or you do your own thing. And you bet, I mean, I did my own thing. So I walked into at this point in time, I walked into the first guy who had started a laser materials processing company in Germany, Falk Straschek. He became my business angel. He just sold his company to Coherent at this point in time and was looking for new investments as a business angel. And he told me, hey Lance, let the stupid Americans go. I mean, we will do this here in Europe. We have a solid base, and finally this happened. So we started EOS in '89, and because I was already experienced in marketing, I had grown quite a bit of business for general scanning. I was looking for the right customer to start with. And I said, well, we are in Munich, let's try a Munich-based company. And I walked into BMW. First, they didn't want to talk to me, but at the end of the day, they talked to me, and they complained about the behavior of 3D systems. They said, it's unbelievable. We have, through our supply chain, through our suppliers, acquired 5 3D systems machines, have analyzed very carefully what's good in the machine, what's not so good. And we wrote our own specification. It was a team of 50 people at BMW at this point in time. And they had evaluated this technology. And they had their own specification. But 3D didn't want to listen to them. They said, well, we have the monopoly, we have all the patents, you just buy what we have, and we will not develop a machine for you. And they showed me the specification, and they said, what would you think if we developed the machine for you? From a laser machining point of view, we had all the background. I mean, we were supplying the major players in the field, and we know exactly where the problems in the 3D systems machine were. You should not forget, at this point in time, there were waiting times of 2 minutes from one layer to the other because data flow was so slow. Okay, so we had the idea immediately to make this much better, but what we totally underestimated at this point in time was the role of the materials. So we were looking at this business at a machine business, but we underestimated the role of the materials. And this we had to fix, and with the help of BMW, we finally made a connection to DuPont, because at this point in time, Ciba-Geigy was the only player in the materials field. And they made the connections, we got the DuPont material, and finally we delivered within 1 year, according to their specifications, the machine, followed up through their supply chain with more than 10 machines within a very short period of time. And so on. We finally got the Mercedes people excited and others in the automotive industry, and we became a serious player. Then 3D did what they were telling they would do. They sued us for patent litigation, and we found a way to survive. We got 75% of the company was acquired by Carl Zeiss. Carl Zeiss, very high reputation optics company, just the desire to manufacture with light. And we survived the patent litigation through this. And a few years later, we had to buy back the company because Zeiss itself got into financial troubles. But what was happening since then? We are now in the mid-90s, 20 years back, okay? The BMW guys had seen the stereolithography machines and came back immediately and said, this is not the kind of material range we want to go forward. We really want to have functional parts for our concept cars, and stereolithography will not take us there. Please go on and develop a machine for us where we can make functional parts. And again, I had in my background all my visits to my scanner customers. And to tell you the truth, there was not one event only in the States. In all major global areas, there were developments in parallel at the university level, at some companies. This was in the US, this was here in Europe, and this was in Japan. They all were our customers because nobody could buy scanning heads from somebody else. They were not in existence. So we knew it all. And I had seen that people had started in Texas to play with powders, DTM. And we tried to look at the DTM machine, talk to the people, can we cooperate? They didn't want to cooperate. So we decided again, together with BMW, let's do it. And we decided to make a plastic sintering machine. And at this point in time, it was a machine with much higher performance, much higher productivity, really targeted towards the manufacturing world. At this point in time, it was just concept cars. Okay, this is what they had in mind, concept cars with plastic sintering. And when you look today, in concept cars, some companies have up to 50% of their part in concept cars using our technology. Okay, but what was the dream? You remember, 30 years ago, the dream was metal. The dream was ceramics, okay? So, and all of a sudden, another customer showed up. It was Electrolux, house appliances. And they had done powder-based tooling, and they had developed a no-shrinkage powder, what they heated normally in a furnace. And they were the first customer that had acquired an SLA machine from 3D Systems in Europe. And they looked at this and came to me and said, hey, Hans, what would you think? Can we do a laser-based metal machine on our material? This time, we knew we had to have the material up front. The machine is just building around the material. And this is what we have done. So in '94, 20 years ago, we developed together with Electrolux the first metal sintering machine. Nobody was thinking in terms of direct metal processes at this point in time, and therefore we are the very first and we are the pioneers in metal additive manufacturing. Okay, but again, it took us about another 10 years before we had developed the technology to a level where we could really use it for potentially for end-use parts. And it was by accident. It was an happening in the laser industry. The invention of the fiber laser. So because at this point in time, until this point in time, we had worked with CO2 lasers, and the beam quality of CO2 lasers was just not good enough to really melt the material. Okay? But now all of a sudden we were able to melt the material. And now it became real. So we were looking and we had seen the possibility to really make dense parts. So until 2004 around, we were not able to do dense parts. But now we were able to dense parts. And the following 10 years was a very exciting time. And in the first 5 years, we identified another point, which was very critical. We were able to change the material during the melting process. So we were able to change the crystalline structure. What it means is we can build material during our process which has higher performance than any conventional material. On the other side, we have a layer-by-layer process where you can watch what you really build. And this made really the avionics guys, the aviation guys, extremely excited because quality assurance of parts during manufacturing is very difficult when you start with a casted part. So finally, we finished our second part of our patent litigation in 2004, and we were able, so it took us really 10 years. We have spent more than 10 million in this patent litigation, but we survived. This was the most important thing. And now we started to sell our equipment in the States. And there was one of our first metal customers, Greg Morris. He was sitting in Cincinnati, and originally he had a plan to work for Procter & Gamble, to do special tooling for them. But GE showed up and saw the process. And they let me know in 2007 that they are really serious. And we had, since then, have developed this process for serial manufacturing, serial production in the aerospace industry. And what most people cannot imagine is that when you go into manufacturing, you no longer look at the technology, you look at a specific part to manufacture. This is something totally different from a philosophy point of view. And I think last year, GE made all this know-how public. Why did they do it? Because it's one of their strongest marketing tools. They achieved now a market share of 50% with their engines. And they sell with the argument that they will use our technology to really save fuel during the lifetime, substantial amount of fuel during the lifetime of their products. This is now a totally different story, but what you really have to learn is it's a different thing to develop a technology or to make a special part. And you cannot imagine how much money they spend on developing the first part. They spend much more money to develop the part than the technology. And this is going on, and they are very, very clear committed. I mean, GE is not the only customer that is committed. We have a big German company, Siemens. They are committed also. What we learned together with them is that they can change the performance of a gas turbine in using our technology for key components. And all of a sudden, the top management of these companies, it's Jeff Immelt, CEO of GE, and this is Klaus Helmrich, CTO of Siemens, they are pushing us in a direction you cannot believe. I mean, we will double our machine output next year compared to last year. It's unbelievable. I mean, it's unbelievable what's going on. My desire is that this is not only happening in the US or in Germany, but it's also happening here in the UK. I think in the UK we have today around 40 metal machines. If we would follow the story of Germany and the Americas, then you probably have to double your installed base next year. This is maybe not happening immediately, but I will not give up my enthusiasm in this direction. I think after the right people have understood really at the top management level what this technology can do to them, then they probably will follow in this direction. And this is what we see at EOS today. We are the world market leader in additive metal. We sell more machines this year than all our competitors together. A nice thing is, most people do not know that I have created in the 90s not only EOS, I have also created another company called General ScanLab. This was today, ScanLab is the world market leader in high-end scanning solutions. We control 80% of the high-end market worldwide, and we sell in the group 30,000 scan heads per year. This means 30,000 machines. And you may not be surprised that companies like Trumpf, the largest laser system manufacturer in the world, is using single source, our component, for all their manufacturing applications. And the reason for this is very simple. They have a very tight quality management system, and nobody, as a number two, is just not meeting their requirements. So they can only go together with us. If you sum this up, and I have started now to talk about the Langer Group, because most people only see EOS. People are very surprised when I tell them that in the Langer Group, we are doing $400 million this year. We'll probably do $500 million next year. We have very good earnings, and we are in a very strong financial position. But we really enjoy that we more or less support this industry with our key technology, because all our competitive machines have our technology, our core technology in it, and we work with license agreements to use our IP in a worldwide activity to get this additive manufacturing doing their job, to build better products for the future, products that save our world, that have a sustainable effect and helps the mankind. And this is not only in aviation, this is mainly also in medical. And you can imagine, I have talked about metal most of this presentation, but we have the same effects going on in plastic. And we have developed totally new plastic materials. Most people don't know that at EOS or in the group, we own 4 powder factories, and we are going into very new material developments in this direction. And we see a very bright future, and I hope you will join us, you will follow us, and we get the same success in the UK, what we have already in the US and in Germany. Thank you very much.